Alrighty, so hello and welcome. Good afternoon or good evening. I had a little bit of time, I guess, so I wanted to look at a problem. It's been some time since it's been like, I don't know, a few weeks or something, it feels like. It feels like it's been some time since I've logged on. Yeah, my life's, never ends, man. The chaos never ends. Oh. I don't really want to get on here and complain, but okay, we have a problem to look at, so let's do that. Distract myself here with the problem. So the problem that we're interested in today is minimum moves to equal array elements 2. All right, let's try that. Let's see how this goes here. Minimum moves to equal array elements 2. Given an integer array nums. Oops. See, we're going to use a vector here. Given an integer array nums with size n, return the minimum number of moves required to make all array elements equal. Okay. If one move, you can increment or decrement an element of the array by 1. Test cases are designed so that the answer will fit in a 32-bit integer. Oh wow, that could be a lot of moves, huh? Nums 1, 2, 3, 2. You can make 1, 2, and 3, 2. Only 2 moves are needed. Each move increments or decrements 1 element. 1, 10, 2, 9, 16. And go. So I think the answer to this question is actually relatively easy. My first guess, I think what you want to do is take the average of all the elements. Or no, maybe not. Yeah, it's the average. Yeah, you want the average. This is kind of like a curve fitting algorithm, in one-dimensional curve fitting algorithm. Like you can imagine a loss function being the number of moves, right? It's those of you who are familiar with data analysis. You could have a loss function here. It's basically optimizing your loss function here, which ultimately becomes, I think you can prove in this case, the optimal loss function is just the average integer. And then you could just compute all that, take the sum of the differences of the sum of the differences with the average integer. So the average integer is going to be okay. 4. It's 5.5. Now you could pick 5 or 6. I think. I don't think you'll get necessarily the same answer, but one of the other is optimal. I think. I think you prove that too, probably. I don't have a proof of any of these things in mind. It just, my intuition kind of suggests that. So let's do 6, right? So 6 minus 1 plus 10 minus 6 plus 6 minus 2 plus 9 minus 6, 16. Yeah, there you go. And then if you do 5 minus 1 plus 10 minus 5, you take the absolute value of the difference, plus 5 minus 2 plus 9 minus 5. Looks like you get the same answer both times anyway, so I guess you could pick either one. So just round it down. I'm not sure if that's always true, but I guess maybe it is. I guess so. So let's give it a shot. Let's see if this is correct. So we'll say int sum for s. We'll say standard accumulate of nums.begin, nums.end, 0. Average is going to be s divided by nums.size. And then we're going to say total, start off at 0, say for constant x and nums. You're going to say total plus equals the absolute value of the difference between x and the average, and then return the total. Let's see what this gives us. This compiles. Okay. Let's try a bunch of random test cases. Length. Okay. Numbers. Alright. 1, 2, 40, 53, 203, 205. Just a bunch of random numbers. Actually, I don't know what happens if we do negative numbers. Oops. Maybe. I don't know if it matters. It might matter. There has, if it's got to be at least one number. Yeah, let's try a bunch of these. See how this goes. Runtime error. No kidding. Integer overflow. Okay. Really? Which one did that? Answer will fit. Let's try that. Actually, we should do that. It was an honest mistake. Gotta memorize this number, man. I think the negation of it fits. Let's just see. Let's just remove these test cases for the time being. I wonder. Can you do? I forget which number. Does that work? It does. If we do one even more negative, I think this one doesn't work. It's a negative 2 to the 31st, and negative. Oh. Whoa. What? Wait, what? These ones at the bottom. Oh. Oh, come on, man. Oh, it's too funny. Really? Oh, it's hysterical. I didn't even catch that. That's great. I like that. I was like, wait a minute, what? Does this work? Is this thing on? Oh boy, that's great. Oh, okay, only from 10 to the 9th. Alright. Okay, I get it. Alright, fine. I wanted to try yeah, I didn't catch that. That's important. It was in the constraints, I don't know, I didn't even think about it, it's going so quickly. Okay, so we'll do negative 10 to the 9th. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I did that correctly, then that should be correct too. That's too funny, man. I don't know what, I don't actually know what the lower and upper bounds of 2's complement is. I should know that, but I don't know it. What is it? It's lower bound and upper bound of 2's complement. Because you don't, the last bit, the 32nd bit is, a sign bit, right? So you can only do 2 raised to the 31st. That's the you could do the negation of this. Now, the problem is if you fill all the bits with 1s, it's actually going to be this value minus 1 and negated, right? If all the bits are 1, that's the largest number you can get that's negative. I think it's also the largest number you can get that's positive too. Can you get a more? No, I don't think so. All right, I have to look it up. Most negative number in 2's complement. I don't know. I don't know offhand. I don't want to think about it. The most positive is clearly 2 to the 31st minus 1. But what's the most negative? What is this? Most negative number. Yeah, did I always? I should say yeah. I should say yeah. I've always kind of struggled with 2's complement. It's a confusing way of doing things. But it's not. I guess it doesn't need to be that confusing. But yeah, I think there's one extra negative number than the positive numbers, which is really odd. Excuse me. So 2's complement, all the negative bits. Oh, okay, 3-bit signed integers. All right. Wait, what? I don't actually know how IEEE implements 2's complement though. I don't actually know. I'm so confused now. 1's complement. Okay. I actually thought I thought 2's complement was actually done using. Yeah. So 2's complement for the positive numbers is kind of just normal. You just have one less bit to work with. But the 2's complement for negative numbers is actually it's actually that's a little weird. So it's actually backwards, it looks like. So -3. Oh man, that's super confusing. Oh whoa. So it's the negation of the first bit plus the sum of all the other bits, and that's how you get that number. That is super confusing. Wow. All right, that's how 2's complement works. It's actually, yeah, you take the first bit, the most significant bit, negate that, and then the rest of those bits you add, and that gives you the negative number. So it's a very unusual. Huh. So yeah, you can get them. Okay. Wow. All right, that's how it works. Okay. Yeah, I never really understood that. I always kind of struggled with that. But anyway, so we want to see. So somehow one of these gives us an error of some kind. Overflow. Wrong answer. Nice. All right, that's kind of unfortunate. Here I am, be thinking that I have the right answer. So clearly it's this test case that causes the problem. But there's both these test cases that are faulty, or at least not faulty, but they're both issues for my code. But this one is more egregious. This shouldn't actually happen. Excuse me. So, what is the issue here? Why is this? Signed overflow. What's the average? Definitely not expecting this to happen. Oh wow, that's a very large average. What? Actually, there are a few issues here. This could be wrong. Like, there are a bunch of issues here. This accumulate, we can't really use this. Well, we can, but it's got to be a. That might be why. It might be. You could do this, I guess. Yeah. There's probably another way to calculate the. There is another way to calculate the average that doesn't need a long. But that's something to consider there. That this accumulation may not necessarily fit. So if you have 100,000 numbers with a billion value, right? The result might be 0. The average might be 1 billion, but you end up in this position where if you take the accumulation, you have 10 to the 5th plus times 10 to the 9th, right? Which gives you 10 to the 14th, which doesn't fit in a 32-bit integer. But I think it fits in a 64-bit integer. You can find out right now. Yeah, well, 10 to the 3rd is roughly 2 to the 10th. So 2 to the 10th 6 times, 2 to the 60th is roughly 10 to the 3rd 6 times is roughly 10 to the 18th. So yeah, actually this would fit in a long, so we don't actually need to get too crazy. Excuse me, to get too crazy with this. But hold on, we got, wait, what is going on? This is what we got for the, oh, that is really confusing. Excuse me? This is, S is this number, and the average we got is this number? Excuse me? You just divide this amongst the number. What is going on? What is happening here? Hello? What? What is happening? Hello? It's not multiplying, it's dividing. I was not expecting that. What is going on? What is going on? That's unusual. Oh, okay. What is happening? Machine? Hello? Computer? Compiler? Is everything okay? Okay, so somehow dividing negative 472,130 by 10 gives you... What is going on? Why is this happening? Is this not division? Is this not how we specify division? We A divided by B? Can we do what's 10 divided by 2? Like, am I going nuts? Okay, something funky is going on here. 10 divided by 2. Let's give that a shot. Yeah, 5. Okay. Works here, doesn't work here. Why is this happening? Excuse me. Excuse me. So this is just overflowed. This is gibber. Okay, so something really weird's going on. Alright, what if we convert that to an integer first? Is that why it's happening? There we go. Okay. Of course. Of course. That's just how it goes. And what do you expect? For some reason, if you don't specify, come on. It's a little weird. It's a little weird. Still wrong though. Alright, that's good. That's interesting. Okay. Yeah, I've seen that before, actually, with the nums.size. Reasons that are beyond me. It's not that it gives you gibberish, it's just the division. Because these are two different integer types, I guess, something like that. The division gets kind of funky. I don't know what happened there before. But the output is not correct, right? Okay. We're not overflowing now, so that's good. I kind of knew that was going to happen, sort of. I thought that might happen, something like that. But yeah, the big number should fit in the long, and then divide by the size. We should get the average should fit in an int. Question though is, why are these wrong? So let's try with the smaller test case first. Just focus on that one. And lament that I took so much time to look at 2's complement, thinking that like I already got this one in the bag. It's 12, 8, 9, 2, 8, 4, 3, 7. Okay, why though? We want to make the smallest number of moves to make them all equal. So there's some number between the minimum and the maximum that if we pick, it'll give us the smallest number of moves that we need to make. And I don't think it's the average actually. I think that was wrong. Well, the average seems like a good guess. The problem with the average is that if you have something like with a big spike, like a bunch of ones, and then a very large jump in the middle at some point very far away, like 10 ones and 100, right? Take the average of 10 ones and 100, or 9 ones and 100. So it's 9 plus 100. Oops. And then divide that by 10. And you get 11, right? Or 10, right? I mean, we're way off here, so this is kind of, it doesn't really matter if we're off by 1 in this instance to figure out that we're very wrong. So we could say 10 or 11, it doesn't really matter which one. So let's say we pick 10. Now 100 minus 10 gives you 90, movement of 90. But all the other ones you got to move by 9. There's 9 of them, you got to move 9 times. Oops. That gives you 171. Let's see. Is that correct is that correct in that case? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 100. All right. Let's try this one. I think this is kind of revealing. 99. 171. Yeah, I picked 10. Expected is 99 though. So 9 times you move 11. Well, you could do... Oh, yeah. You could just subtract 100 down to 1. I didn't think about that. Because, yeah, so... It's a little bit, yeah, it's not... The function that I'm looking for is not actually what I was thinking, right? Because what we're trying to minimize... Like, let me be a little more rigorous here. You have some variables, x of I, and then you have some alpha, and you're trying to minimize the sum of x of I minus alpha. That's basically what you're looking to do, right? So you can have some function, f of x of I guess, or x of, I don't know. It's like a set called big X. I don't want to get it confused. I'll just say, we'll call it Q, or S for the set. That's just the sum, right? Which is equal to the sum of I, x of I, minus size of S times alpha. By the way. And we're trying to minimize this function. We're trying to pick alpha such that this is minimized. I mean, this is very similar to data analysis question. I mean, this is not exactly this is not exactly a data science question. Is not alpha just the average? Why am I going crazy here? What's wrong here? Why do I feel like I'm losing my marbles? Well, we could say f prime of s, I guess. D or D, D, what is it? D, we don't know what alpha is. X sub I is all, it could be random. Does this function have a derivative? We want to know when df, I guess x is equal to 0. That's kind of what we're looking for here. It's a very data sciencey kind of a question. I feel like I should know the answer though. Not only just know the answer, but know the answer quickly. It's kind of annoying. How do you minimize this function? Oh, actually, it's not even, by the way, it's not even that. It's actually the absolute value. Yeah, I mean, this is a distance sum thing. And it's not just the average. Nope. There's a few things to say about this. I want to say the median satisfies this. Yeah, the median satisfies this. Median value. Which is not the same thing as the average. Actually, the median is a little bit different. Actually, you can use intro select to find the median here, do a linear time. But the problem with the median, like, what if you have 1, 2, 9, 10? The median is either 2 or 9, right? So 1, 2, 9, 10. Let's see. Let's say. Alright, okay. I don't know. I don't actually know why exactly, like rigorously, why the median here is what you want, but something about it. I'm like, no, the median is what you want. So the median here is 2 or 9, right? And if you pick 2, you would get -1, 0, or just 1, 0, 7, 8, right? Which is 16. If you pick 9, you would get 8, 7, 0, 1. Yeah. This is the median. Okay. I don't know why I'm struggling so much with this. I don't know. I don't know why I thought it was the average. Something about the median. Yeah, I knew it was something simple though. I knew it was something simple. But we don't want actually the average. We want, you can do algorithm. And it's going to be, so it's, hold off on that one for a second. Standard nth element of nums.begin, target nums.end, and it's, I forget exactly how this function works. It's going to be a while before I remember it exactly, but here's a good example of its use case. Okay, can we? What is going on? What's going on? Okay. First, last, nth. Oh, I think I understand. Okay, I think I get it. I think I get it. Yeah, yeah. It's been a while, but pointer or just median. Yeah, pointer. We'll call it pointer. Nums dot begin plus, and this is going to be basically just nums dot size divided by 2, more or less. So if you have 0, 1, 2, so if you have 4 numbers at 2, yeah, I mean that's fine. That's okay. Doesn't matter which one we said. And pointer is going to become so the median is dereference that pointer. And if there's one element, yeah, something like this should work. Let's see. Pile error, nice. Function operator returns a const value. What's the issue? Do we need standard vector int iterator? Is that what we need to do? No. Constant. It's a little confusing. I want to use auto here. I think the reason might be because this says const. That might be part of the problem. Yeah, that seemed to be the issue. Okay, now we're correct. Alrighty. Yeah, I mean, okay. You know. Oh yeah. Oh, nth element rearranges the numbers. I forgot. I forgot. That's why. Yeah, it's not. Oops. Okay. This should have been really fast, the solution. I think I should have come across this pretty quickly. I think I'm going to go ahead and just submit it. Go for it. Hey, there we go. Sweet. Okay, super quick. Super quick. Super quick. Alright, that took 30 minutes. That took way too much time. We could have done that in like 5 minutes. But I got kind of hung up on some things. Yeah. Let's go for it again. See if we can get better. 55%, okay. 91%. Alright, we got 4 milliseconds. We want to get 0 milliseconds though. Can we get, if we hit it a few times? Alright, we want to do one more thing here. We want to get this absolute value. I want to see if there's a way, instead of using absolute value, if we can try to think what we can do here. We could change this slightly. So if x is greater than median, total plus equals x minus median. Otherwise, total plus equals median minus x. How about that? How about that? How about that? Well, how about that? Well, how about that? It seems slower. No. Submitting too many times. No. This seems decidedly slower. Seems like it's definitely slower. I don't know. I mean, making a function call seems pretty slow too. I'm also wondering if maybe an accumulate function is what we need. Some kind of an accumulation function that makes things any faster. I mean, you could try that. See what we get. Oh no! And here we want I mean, this doesn't seem much better in terms of readability and whatnot. I probably should just use what I have here. Also not correct. Incompatible type void. Okay. What is this binary operator going to look like? Oh, okay. It's actually both of them are constants. And in fact, you're going to return I don't think that's much faster, truth be told. 1, 2, 3. 1, 2, 3. Yeah. That's not really much more readable nor much faster. I mean, you're using the STL, so some points for that, but not really too big of a deal. I wonder if you put the dereference operator here, if that matters. Kind of wonder what this looks like. Oh, it's fast. I mean, I don't know, man. Trying to get that 0%, that 100%, you know, fast in all the solutions. Not quite there though. Yeah, we're so close. I don't know what I could do to make this faster though. This is like as fast as I could think of. Because if we throw anything in here, yeah. It's hard. You know what you can do multiply the median by the total number of values and then subtract multiply the median by the total number of values and then subtract the sum of the values. I think that works. Because what that'll give you is the median minus each value. But that won't give you the absolute value of all the differences. That's the problem. Yeah, that's the problem. Yeah. That's the issue, huh? Oh man, it's hard. It's hard. Oh no, no. The first half of the numbers are all smaller, and the second half are all larger. Oh, I know what to do. I got it. I got this. All right, I got it. Yeah, I know what to do. All right, ready for this? Haha. It's very slight optimization, but here we go. So all these numbers have to be less than or equal to the median. So take the median and subtract this number, and then every number beyond haha, I got it. I think I got it. And then you reverse it. Okay, I don't know what's gonna happen when we do this, but we can try it. Hey, there we go. Is it correct? Okay. Same speed though. It doesn't even matter. Okay. Really? It's not even a little bit faster? Okay. Maybe we do the median here. And then we could do median. I don't know. Let's try one more time. Not even getting 4 milliseconds for these ones. That's kind of interesting. I would think this absolute value wouldn't. I wouldn't think this would be so quick. Could do int mid. Yeah, I don't know, man. Cause the. Oh, there we go. Hey, you got there. Yeah, all right. We are a little bit faster. Okay, we're just a little bit faster. Yeah, because we don't have to use the absolute value here. We can accumulate from this beginning. And actually, you could rewrite the accumulation here too if you wanted to. You could use this also as 2 accumulations. I think this is a little bit faster. Just slightly, ever so slightly, just enough to get that 100% because we're not running this function in between, and we're basically we're splitting the array into 2 pieces where we know it's always going to be less than on one side and always larger on the other, so we can avoid this internal function call. Okay, well, that was fun. That was kind of a gimme. That was a bit of a gimme. We should have been able to solve that a lot faster. It took 45 minutes. Not great. So yeah, thanks for watching. I'm going to go ahead and end this one here. But this is fun. Definitely an interesting problem. So yeah, take care. Talk to you soon. Bye.